everybody, this is Miss Richardson, and today I'm going to be showing you how to create your own algebraic equation. All you need to do to start off with is just a variable and a value for that variable to equal. I'm going to start with the variable x. I'm just going to say that x is equal to 5, just some random value that I chose. You can start with any variable and any value. Keep in mind that a variable is just a letter that we use to represent some varying value in math. Maybe the variable can equal 2, maybe it could equal 87, maybe it could equal -12 or some decimal number or something like that. And the variable, we can really use any letter in the alphabet that we want. We always want to use lowercase letters, but we can use A, B, C, any of those letters that we like to use, but we'll typically use variables X, Y, and so on. I'm setting it equal to 5 just because I like the number 5. And what are we going to start by doing is literally anything. That's the cool part about creating an equation. Because if you think about it, what is an equation? An equation is just something with an equal sign, like as long as it says something equals something, it's an equation. And so I know that X is equal to 5. We're going to work backwards though, and this is probably something that a lot of you have never done before, but I think it's super just cool to do. And so instead of solving an equation, we're going to be creating an equation by doing the opposite, kind of like unsolving. And so what am I going to start by doing? How about maybe I want to add 2 to both sides of my equation. So I want to add 2 here, but I know whatever I do to one side, I have to do to the other. So of course, I also have to add a 2 on the other side. And this here is still an equation. It's still a true equation because we know as long as you do something to one side and make sure to also do it to the other, then you're good, And so what does this new equation say? Well, now I have an equation that says 2 plus x equals 5 plus 2. Of course, 5 plus 2 is 7. Nice. And so stop and look at what we have right here. So this here is a new equation that we just created using this previous little equation that we started with, the simple equation that just says x equals to 5. We added on to it some 2's on both sides, and now we have a little bit more complicated equation that says 2 plus x is equal to 7. If I were to solve this equation using techniques that you may or may not know, well, then we would get the solution that we started with. We'll get x equals 5. If I were to plug x equaling 5 into here using substitution, we would see that it says 2 plus 5 is 7, which of course is true. And so, yeah, we made a new equation using one basic equation. But of course, it can get more complicated. What if we keep going? I added a 2 to both sides, but maybe this time I want to... maybe I want to multiply everything by 4? Well, right? I'm going to multiply this 7 times 4. And, we can multiply using the parentheses. So I'm just multiplying that. I guess I didn't need those double parentheses. Let me erase those. There we go, using the parentheses. But we know, whatever we do to one side, we have to do to the other side. And so over here, I also have to multiply the entire side, not just the first part, but the whole side by that 4. And I think some of you are already thinking like, we're probably going to have to distribute that 4 into there at some point. We could. It's really up to us, we're getting as creative as we choose to be. But look at what we have now. If we stop and look once again, we have the left side that says 4 times 2 plus x is equal to 7 times 4, which of course we know is 28. We can use a calculator to verify that. That's nice. And so we look again, we're like, yay, we have another equation. This one's even more complicated than the previous one we had before we multiplied those 4's on the left and the right side. And so the point we're trying to get at here is that we can keep going and going and going, making the problems as complicated as we want. Do we want them to be complicated? That's the question. But we can, we can go as far as we really want to. Yeah, let's try one more of these. We'll call this example 1. Oops. And so this other one, let's try example 2. The techniques we used in example 1 were very good, but let's imagine maybe if we use some other techniques. So what I'm going to do, I'm going to put this in a box. And then I'm actually going to scroll up just so we can have a clear screen, nothing to distract us. And so we're going to try example 2. And so I'm going to start with something else, maybe a different variable. I like the letter P. Let's start with P. Let's say this time P is equal to, let's say it's equal to 10. Just some random value I pulled out of my hat. And so if P is equal to 10, I'm thinking like, what creative things do I want to do to both sides of this equation? And so this time, let's try maybe powering, using an exponent. Maybe I'll put P to the second power. We know whatever we do to one side, we do to the other side. And so I also put 10 to the second power. And what do I have now? Well, on the left side, we see we have P squared. And on the right side, we see we have 10 squared, which if we were to put that in our calculator, we know that would be 100. And then look, we have a new equation that we got from knowing that P was equal to 10 in the original statement that we just wrote beforehand, yeah. And let's say I wanted to get even more complex. Maybe I want to go and add a 3 to both sides after that. I do it to one side, I do it to the other. Now I have another new equation that's even more complicated than the previous. That says 3 plus P squared on the left side equals 100 plus 3. Or 103 on the right side. And so each step of the way, we're creating new equations. That's like two new equations that I made on top of the original one I started with. I started with the original equation that said P was equal to 10. And then it turned into a new equation that said P squared was equal to 100. And then it turned into another equation that said 3 plus P squared was equal to 103. And the coolest thing about it is all 3 of these equations have the same solution. They have the same answer and the same p-value. That is P equaling to 10. And so that's what we'll be doing for this project that we're working on. We're making equations and keeping the solution to ourselves. And it'll be up to other people to find that solution by solving the equation, and we ourselves are going to be creating the equations like we just did here. Yeah, so I'm going to erase this over here. This was just I'm going to erase all of this, just so you can really see what we're looking for. So this is what any one of the problems that you create will look like in your notebook. I mean to say, you're going to make sure that you only label the problem. So let's say this is problem number 1 that you're creating. Labeling the problem will say, for example, if I decided to use this problem here, it'll say 3 plus P squared is equal to 103. And maybe actually I don't want to label it like that because it looks weird when I use a 1 like that. Maybe I want to label it like this. And so this will be my first problem that I have written. On another page with our solutions, we're gonna have the answer to that. And so the answer to number 1 would be P equals to 10, the value we started with. So yeah,